what we are going to see is a generators in Python. So what actually the generators will do, it will generate the values until some condition is met, based on the condition is met. So when compared to iterator, generators are better. It is similar to a list comprehension, I can say, but list comprehension and this will have a different syntax. Here the keyword which is used to become a generator, where normal function can be a generator when it uses a keyword called yield. Whereas normal function, once it returns a value, the function life will end there. So the control will not go back. Whereas here, when you modify a function as a generator with using a yield keyword, what happens? The control will go back to that until the condition is met. So what is that condition? We'll see. So how that generator works. So now, so specifically, if you see here, we will copy this program entire as it is, and we will talk about generators. So what it is here? It is a simple generator function which yield 1 value, 2 value, and 3 value. Let us consider. So in order to move to the next value, we need to say x dot next. You have created a normal function rather than yield what you were saying return. In return, only one return you can specify, whereas yield, n number of yields we can do. N number of yields we can do. So once the condition is met, let us consider, once the yield condition is met, if you still called yield, yield, what will happen? What will happen? It will give you a stop iteration exception. It will give you a stop iteration exception. As it is a Python 3 version, one, right? So what happened? Whatever the values is there, whatever happened in the function, that value, that modification you want to send back, we can send back. See, the control goes back, no? The control is going back. You say next. It is not printing the next one. It is trying to print the next one, but it is from the function. It's from the function. Okay. So now again, what we have to, 1 second. Hello. Yes. Yeah, tell me. Can I call you after 1 hour? Thank you. Yeah. So now if you see, observe here, what is happening? 1, 2, 3. Now we have only 3 yields. What if I keep next? What if I keep one more next? We are doing only 3 yields. What if I keep stop iteration exception? So from this, what did we understand? We can yield some values until the context is there. So now, okay, until the context. So now if you see here, if you observe here, what is happening? Let us change this function. Okay, we have already functions which have been inbuilt with us. We'll open that. So how many times we can yield a function? N number of times. There is any limitation? No, but there should be a limitation. No, it can't be. If there is no limitation, again it will be a, what is the situation? It will be like a unconditional loop. Unconditional loop. Correct. So now there should be some looping condition. So what we want to see here is, so what we can understand here is, so now you see here, what happens? The same thing we can do like this. See, we have done a list. We have a list. Let us consider, and we have a list iterator. Okay. So we have given this to list. So rather than that, what we will do, the generator expression is like this. Okay. Rather than a list iteration, we are doing a generator expression. So we say every time what is the generator? What is the next value? 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 Okay. So like that we can see. See, this will be used in where actually, can you tell me a real-time scenario where generators will be very useful? You will be using daily. You'll be using daily. OTP. OTP. You can use only maximum 3 times. So when you say 4th time, what it will say? Stop iteration exception. You are exceeded. Correct. So in that scenarios, these generators is used. Maybe generators like OTPs or somewhere else. Like daily, you can send only 50 mails, or where some like we saw Stack Overflow also, only 300 day per quota. Correct. So such cases we will use this stop iterator exception. So see here, we will take one example. Normally we will do Fibonacci series. Correct. We'll do a Fibonacci series. We'll do a square of a numbers. What is the point is here? We will do both at once. First we will do one by one. So how we will get this? How we will call this function first? Fibonacci series. We should have a Fibonacci. So like we'll say generator is equal to. So we should have some limit Fibonacci till 10. We'll say 10. So now if I print next of generator. Okay. So what is the value will come? First one. So how many times I can call like that? Huh? 10 times. Until the value is 10. Oda x plus y node. Okay. What is the Fibonacci series? The sum of previous two numbers is equal to third number. Correct. That is a Fibonacci series. Fine. It also came. How many numbers it is now? 1, 2, 3, 4, 5, 6, 7, 8. 8 only. 10 now. So we will do one more now. Stop iteration exception. So we have specified a limit 10. So 10 values of Fibonacci series should come to us. So what happened here? We are trying to get the Fibonacci series up to 10 using a generator. We are generating the values one by one. Where this kind of environments in real time will be used, as I told, OTP kind of scenarios, right? Or your authentication. Phone password. Phone password. Even that is also. No, this is your authentication. Normally, some apps now you need authenticator, no? Right? Two-step multi-factor authentication. Rather than two-step authentication, we can call it as multi-factor authentication. They will send a OTP to you. Right? Even you reset a password. So you can reset a password in a day or two, thrice or twice, right? Correct. You say you enter password, wrong passwords. How many times? You can't enter so many times. Twitter allows, whereas other people will not allow. Right? So they will keep how many times? He has exceeded for today. 24. Even in ATM also, you go and enter a password, wrong password. How many times? 3 or 4 times only. Fourth, fifth time it will be blocking for 24 hours. Again, it will unlock. Correct. So that's the point. So from this, what did you understand? So it is not similar to return, but it will return a value. But it will return a value until the condition is met. Until the condition is met. Until the range is that. Okay. So you need to understand here one bit technical thing. What is this underscore? Any value, anything inside it may be. Anything inside it may be. Clear? Means there is no value I am taking from the numbers. Okay. But I do my own functionality. Correct? See, X and Y were outside that loop. I have declared. I am looping, but not using looping value. But I need to loop 10 times. So that is a basic one. That is a basic one. Clear? If it is more than that, what I will say? Stop iteration exception. So in order to do that, what we can do? We can write all this in a where try block. Correct? So try block. We will write in a try block. And we will specify. Bariable. Torsana. What is except? What exception? How's stop iteration exception, we caught it and we said you have exceeded the limit. Correct? So why we need exception handling? Whenever there is an exception, whenever there is an error, you need to convey your own message. Howda? So stop iteration exception bartittu. Till now, it was coming. But what we were doing, we were not understanding what is happening. But like no layman cannot understand. If you say stop iteration exception in ATMs and all, layman can understand. Can understand? No, he can't understand. So you need a perfect message. So now it is a so you have exceeded the limits per day. Clear? So generator, what it does, it returns a value, but there is a limit. So what is the difference between a like yield and return? The yield statement is responsible for controlling the flow of generator function. It passes the function execution by saving all the states and yielded to the caller. So it will yield the value to the caller. Okay. Latter is resumes its execution when successive function is called. So when another function is called, it resumes its function. Yeah, same. We can use multiple yield statements in generator function. Yes. The return statement and the return value terminates the whole function. Only one return can be there. Correct? You got it? Okay. So we'll see one more example so that you can understand. We are doing an arithmetic series. Up to where? Up to 50. Up to 50. What you are saying? I am calling the arithmetic series as 3, 10. From 3, 10. When I say 3, 10, I am finding all the sum of the numbers between 3 up to 50. Okay, just less than 50. Whose starting value will be 3. Thereafter, tens will be added. Common difference. So now what happened? You say while a less than 50. Yes, always is a less than 50 initially. So what you do? You will add 10. 10 for every yield. You will add 10. So when you call next, what happened? 3, 13, 23, 33, 43 reached. So when it is plus 10 again. So now it reached 43. 43 plus 10. What is that? 53. So now what happened? A is 53. 53 is less than 50. Correct? Stop it. Clear? Arada? Same. Using a multiple yield statement. First OTP. We are calling a generate OTP function. Okay, we have done this also. We forgot where it saved. So what is happening here? Random.choice range between like we are going for a 4-digit OTP. Okay, if it is a 6-digit OTP, you can give 1 lakh and different number. Okay, so some people follow 4-digit OTP, some people follow 6-digit OTP. 6-digit OTP is more secure, I can say, because here you can guess the numbers very easily. Random andre any random number. That is a package we have. So the random.choice. I'll give a number. I'll give one set of numbers. In that choice you can pick. If you give a choice. So that's why I called it as a random.choice in between 1000 to 99. Any one you pick. So sometimes both may be same. So what happened? We are saying next until it reaches the. So how it understood maximum tries has been reached? Because of 3 yields only. Because of so how it is deciding it should go only 3? We have only 3 yields. Otherwise we should have a condition. What is the difference between a generator function and normal function then? Normal function only one return statement, whereas yield can have n number. When the generator functions are called, the normal function is passed immediately. Correct? And transfer the control to the caller. Correct? Immediate. So whenever a generator called, the function execution stops and the control goes back to the caller function. The local variable and their states are remembered between successive calls. Right? If Fibonacci series happened 1 plus 1, 2, 1 plus 2, 3, 2 plus 3, 5, like that, who it was remembering. Right? So stop address exception is raised automatically when the function terminates. Advantage. What is the advantage we have? Actually, if you use iterators, you need to use the ITR or next function. You use the first one, right? So whereas generators are memory efficient for large number of sequences, normal function returns a sequence of list which creates the entire sequence. I don't want entire sequence. I want one by one. Then yield is a good choice. If I want entire list at once, then normal function is a good choice. Correct? It depends on the use case. It's not like you should use only generator, you should not use a list comprehension and all. Again, it depends on the use case. So if your thing is like OTP kind of thing, or validation kind of thing, multi-factor kind of thing, which is better, comprehension or generator? Generator is better. Clear? What is the difference between then what is the difference between the list comprehension and generator? As I told you, it doesn't return a list. Only useful for generator for generators is for iteration. So generator anything can, it's only for iteration. Next you go. That's it. Nothing other than other big usage. Once consumed, generator cannot be reused. So previous value you can't get. It will move forward only. It will not come backward. Whereas in list comprehension, you can go anywhere. You can take entire value of the list. So based on the use case, we need to choose wisely. It's not like we learned a topic, we should use generator everywhere. We have a topic. Where to use, it's up to you. How it comes through practice. So what is the output of this? Here the call. Both options are correct, no? C and D. That's the problem. The question is tough. Okay. Arthata? We saw constructors also, right?